Talk about reflection, you basically have to define what reflection is. So usually you get a question that says, what is reflection, or what do you understand by the term reflection? Or simply define reflection, which means it is the ability to inspect an object at runtime. So you are saying, as your program is running, you want to be able to receive an object and get information about that object that you may not have at compile time. I think that is what we were doing before with queue objects. So you get a queue object, you can get all the properties on that queue object, or that whole story. That is reflection. So the first thing you want to understand is, how does reflection happen? Right? That is the first entry point. How does it happen? How does Qt handle reflection? What is involved? So every time you build your application, right? Whenever you click that hammer to build your application, your compiler obviously compiles your code and then it runs, right? There is also what is referred to as the meta object compiler, or the MOC. And this is one of the major components of reflection. You cannot explain reflection and not mention the meta object compiler. Otherwise, you haven't said anything yet, because it is the one that causes reflection to happen. So the difference between your normal compiler and this compiler is that you don't do anything to trigger this one. It just runs automatically in the background. So as you're writing your code, as you're doing your stuff, it just executes, and then it creates what are called meta objects. And you don't see those meta objects, but they are there. So your meta object compiler requires two things for it to do what it does, right? So we are saying that it goes through the solution, and for each queue object, so the first requirement is that your class must be a queue object, and the second requirement is that it must have a queue object macro. These are the two requirements that are required for reflection to happen. Without these two things, there is no reflection. And you can relate previously to your signals and slots requirements. They were the same requirements. So what your meta object compiler does is it goes through your solution. It finds all classes that are queue objects and have the queue object macro, and it creates what is called a queue meta object. Again, you don't see this, but it's there. But you must be able to explain this, right? And the queue meta object which is generated is the one that contains the metadata about the object. So in other words, you've got a queue object here, and for this queue object, your MOC generates a queue meta object, right? And it is this guy that contains information about this guy. So the queue meta object contains the metadata, the information about your queue object. And among other things, the two things we are really concerned about that are contained in the meta object are the class name and the properties. There are also other things like the functions or the methods and some other stuff in there, but we only ever worry about the class name and the properties that are within that queue object. So in other words, I'm saying, if you get the queue meta object of any queue object, this will contain information about the actual class name, because you might be saying, but why do we care about the class name when we know that it's a queue object? So I'm saying you might have inherited from a queue object. Maybe you've got your class called node, which is inheriting from a queue object, right? That's the class name. So if you take that queue object and you go to the meta object of that queue object, you are able to get the name of the class, right? And the second thing are the properties. This is what we did during the assignment. We wrote code that could go and retrieve all the property names and values for each object. I think it is very worth you guys going and looking at that code. It's very critical. It's very essential. It's some of the code you may be required to write in the exam, right? How do you get all the property names and all their values in a queue object from the queue meta object? So that is where you go and do constant Q meta object, if you remember, Q meta object, and then you give it a name, M equals whatever your object is, dot meta object, if you remember this code. And then from there, you've got a for loop, which goes through each property. And then inside the loop, you get the Q meta property. From the Q meta property, you get the property name. And then using the name, you get the value. So you should be able to write all that code. Like from this line here down to the for loop and getting all the names and all the values, you have to know how to use this code. So that is basically the theory around meta objects and reflection. So if you want to use reflection, because we are saying that the meta object, the Q meta object, contains properties. That is the one reason why every time we start talking about reflection, we start talking about properties at the same time. So every time you hear a question about reflection, it's not only about meta objects, it's also about properties, because these two things go hand in hand together. Okay? Because we are saying that let's define properties inside our object, and then we can later on use reflection to get those properties. So this brings us to the subject of properties. What are properties and how do you define properties? And again, we covered properties during the assignment. We talked about how do you define a property in a class. And we did this, right? Q property, the type of the property, the name of the property, the get function and the set function. These two functions must be defined in the class. A normal get and set function, right? That's how you define a property inside a class. And all the properties that you define inside a class are referred to as static properties, because these ones you define. They are there at compile time. You create these properties in the class. They are there. These are static properties. Don't confuse static properties with like static variables, not related at all. This is a different thing altogether. So here we are not talking about static variables like we did with the singleton design pattern. We are simply talking about properties. And we are saying the properties that you define in the class are referred to as static properties. And we're going to talk about dynamic properties later on, right? Once you have defined a property within a class, how then do you use a property to set the value of the property or to get the value of a property? And to do that, I'm saying, let's say you create an instance of your class, which is a Q object. It could be a direct Q object or a class which is inheriting from a Q object. There are two functions involved. The first function is set property, which is how you set the property on your instance. And the second function is property, not get property. It's a very common mistake. Most guys go set property, get property. No. Set property is the function you then use to set the value of a property on your object, and property is the function you use to get the value of a property on your instance. So let's say, for instance, we define an instance of a Q object called O, and we know we've got a property called name inside our class. We can then say O.set property name, and then we give it the value like the actual name, right? So in other words, this is the actual value. If it's a date, put a date here. If it's a string, then put a string there. If it's a float, then put a float there. In other words, this argument is a Q variant, right? We'll talk about it just now. That is how you set the value of a property, right? Now, the next question is, what if we define a property called name in our class, and then we make an instance of our class, then we do something like O.set property, and we go surname. Then we put some surname here, right? How does this line behave? What's going to happen? Because this property does not exist in our class. Now, if you try to set a property which doesn't exist in your class, in other words, it hasn't been defined yet, your compiler at runtime, which means when the program is running and it gets to this line, it will go and check, do I have this property in this class? It will go in your class. It won't find the property. What does it do? It creates it at runtime, which means this property is not going to be there in the class. Like if you go and check your code, it's not there. But when your program runs and it goes to this line, it will actually create a property called surname for you and sets the value, which means if you then use the property function to get this property, you'll get the value of that property. Now, these properties are what are then referred to as dynamic properties. So every time you see a set property function with a property that doesn't exist in the class, it means that property will be created at runtime when the compiler gets to that line, and those are what are referred to as dynamic properties. And a common exam question is, what's going to happen on this line? Is it going to fail? Is it going to succeed? If you say it's going to fail, can you fix it? If you say it's going to succeed, then explain how. And this is the explanation. It's created as a dynamic property. So basically, that's everything about properties. All right. So every time you think about reflection, there are mainly two things your mind should think about. Properties. In other words, how do I define a property in a class? Number two, how do I set the value of a property on an instance of a key object? Number three, how do I get the value of a property? Number four, how do I use reflection to get property values and names from a key object? Number five, how do I get the name of the class using reflection? Every question you're going to answer on the reflection is going to be within those five things. Every single question. But it doesn't make it easier. So your biggest job is the ability to identify what the question wants you to do. That is, in most cases, what people miss. There are so many cases where you get stuck with a question. I don't give you the answer. I simply rephrase the question and you get it right. That happens a lot of times, a lot of times. I've had cases where you are having a class and I give you a question, everybody is stuck. I explain the question, I rephrase the question, I simplify the question, and then everybody gets it right. What I don't supply is the answer. I simply explain the question, which means in most cases, if you're getting a question wrong, there are two things. It's either you just don't know what reflection is. It doesn't matter how much you just don't know reflection. Like you were not there when we were discussing these things, or you just didn't study or read or catch up, right? The second thing is you know reflection. You just don't know that this question is what they are asking for.